Hello, this is Idea Nexus, a YouTube channel about computer science and gaming, sometimes computer science, sometimes gaming. Today I want to talk about what I'm currently calling cardinality cartography. And what you see here is Ulam Spiral. As the story goes, once upon a time in 1963, Stanislaw Ulam was sitting in a very boring lecture and started doodling on a piece of paper. And he started by writing the number 1 and 2, 3, 4, 5, 6, and around in these growing spirals. And then he started highlighting the prime numbers, as I've done here in blue. And he noticed that the prime numbers were falling along these diagonals. And wasn't that interesting? And this is a 23 column grid I've made here, but if you expand this out, say to 300 columns, which I did online using, if you Google Ulam Spiral generator, you'll find a lot of JavaScript applications that can do this for you. This is a 300 by 300 grid, and you can see these very noticeable lines in the pattern. And so this is intriguing because prime numbers are something we tend to think of as being very random, very hard to predict, and yet here is something of a pattern, these dotted lines. And in order to understand why Ulam Spiral works to create this pattern, I have created this is what's known as a number mandala. And what we've done here is we've taken the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to create these 12 branches, and then we spiral the numbers out and out and out and out and out. And you can see here at the 2, 4, 8, and 10 and 12 spots, I've shaded these in as green because these are going to be even number branches. So these are the even numbers. And then here at the 3, 6, 9, and 12 positions, we've shaded in these as red as multiples factors of 3. So we know that no primes are going to be found in these branches. And here I've highlighted the primes. And so this crisscross of branches, these are the only places where our primes are left to be found. So we've created a kind of map of the numbers, and we have used it to filter down the most probable 4 branches where our primes can be possibly found. Now, to understand why Ulam Spiral works, you have to know that Ulam Spiral is quadratic in nature, and I had to Google that, and apparently that means it is based on squares. And what I've highlighted here, these red numbers, these are squares. 4 is 2 squared, 4 squared, 6 squared, 8 squared, 10 squared. So that we've got the even numbered squares along this diagonal, and down here we have the odd number squares, 3, 5, 7, 9 along here. So each of these is a square. 4 is a 2 by 2 square. 1, 2, 3, 4. So 2 by 2 is a square. 16 is 4 by 4 squared. So you have 16 creates a square. 9 creates a 3 by 3 squared. 25 creates a 5 by 5 squared. And this creates a pattern. And the part of that pattern is that it's going to line up all the even numbers. So I have drawn a line through the diagonals that are even, and that creates these little X's. So we know that prime numbers cannot appear in these little crisscrosses, which leaves us with only these odd numbered crisscrosses. So of course we've filtered down where the prime numbers can be found. And that pattern of filtering down means that the prime numbers will continue to be found along those diagonals. So I brought these up. These are an example. These are examples of computational thinking. These are also computational artifacts that help us think computationally about numbers. These are maps. We are organizing numbers in ways in which to see the patterns. And in my next video, we're going to look at a JavaScript application I wrote to generate number mandalas and allow people to generate their own and explore explore numbers in different patterns in order to find patterns. And that is the power of computers, is that while it took me an hour to draw this diagram, it took me half an hour to draw this diagram, it took me 30 seconds to create this map of the primes of an Ulam spiral that is, that's 23 divided into 3, 12 times as large as what I was able to draw in an hour. In 30 seconds, I was able to generate that. So in our next video, we'll take a look at a JavaScript number mandala generator, and we'll talk about the code and how it works. Thank you for tuning in.